Today we start transformations. Now, for transformations, we're going to work off your core graphs. And I know you're going to be getting this because how many times do I put a parabola that says x squared plus 1 and I ask you where it goes and you tell me up 1? That's a transformation. If it moves to the left, if it moves to the right, that's a transformation. If it reflects, just like we did now, that's a transformation. So all we're going to do is fine-tune these transformations. And we're going to work off your core graphs. Now, most importantly, when we do your transformations, I want to pay attention to your domains and your ranges. Anything that's going to affect an x, any movement horizontally, any reflections that affect your x are going to change your domains. Anything that's going to affect your y, your slides up and down, any reflections that way are going to affect your range. So we should see this happen. So before we start, we're going to talk about your 4 core graphs. You have 4 and we're going to add a 5th one here. We have 4 core graphs. So our first one is your absolute value. This is your basic absolute value graph. So f of x is the absolute value of x. So from this graph, you can see your domain. What's your domain on this? What's your domain? All real numbers. And what's your range? 0 to infinity. Out of an absolute value, it will not come out to be a negative number. So your range contains only positive numbers, which makes sense. So let's keep track of this guy. You told me the domain, all real numbers, and our range, 0 to infinity. Okay? Good. Squaring function. Squaring function says this. This is your quadratic. 0 to infinity. Guys, I want it quiet. This is your quadratic. This is your basic parabola. It has the same characteristics as your absolute value. The domain is all real numbers, and the range is the same thing, because any negative that we square will be positive. So from 0 to infinity. These are called your core graphs, your parent graphs. We run our transformations off of these guys. So now we can shift it up 1, over 1, down 5. We can reflect it off of your parent graph. Your square root function says this. F of x. Now, hopefully you're seeing everything start tying in. Your domain restriction for your square root says that anything under the square root cannot be negative. So we took what was under it and we set it greater than or equal to 0. So isn't your domain from 0 to infinity? Doesn't it work out the same when you graph it? 0 to infinity? Yes? Now your range says, just for your basic radical, can you come out with a negative number out of your radical? No. So your domain also is 0 to infinity. Your range also is the same as your domain, from 0 to infinity. Okay, so this ties in with how we know to do our domain restrictions. Now, your cubing function, which we've looked at in many of your graphs, just go like this. They're up, down on one end, up on the other end. F of x is equal to x cubed. What's the domain of this one? All real numbers. And what's the range of this one? All real numbers. This is kind of nice. And we've been seeing that we've been working with these, and they're all real numbers. Okay, now your rational. This one, I don't think you did this one in Algebra 2. You did those 4 in Algebra 2, but this one's a little bit different. This one is a rational function, and you looked at rationals. We said they had fractions. Now, from your domain restrictions, you know that a denominator cannot be equal to 0. So we take this denominator and we set it equal to 0. We take that restricted number, because we can't use it, out of our domain. And you are left with a domain of all these other numbers, negative infinity to 0, or 0 to infinity. What this makes for you is a natural asymptote. You get a natural asymptote from this guy. And what happens is, it says you can never use x as 0. X as 0 is down here, is your y-axis. So it's never going to go through your y-axis. But if you think for a minute, if you can't get a 0 in here, any other number I put in here, is there any number I can put in for x that will give me a y of 0? Can you think of any number that goes into x that will give me a y of 0, exactly 0? No? In other words, if I did this, I want to find a 0 out of this. Let me cross multiply, see what my x value would be. I cross multiply, I get 0 is equal to 1. Is that true?
No.
No. So I can never get a 0 out of this equation. So what happens is, it makes another natural asymptote over here. It's never going to get to a y of 0 either, which is why when you graph this, you get these. You get this type of function. Because our domain says you cannot put a 0 in here because of this denominator. And as a result, we can never get a 0 out because there's nothing we can put in there that will give us a 0. So we got to take that out of our range as well. So your range is going to say the same thing. You can use any number, but you can't use 0. So our range also says this. Does that make any sense? Like with the domain and the range? If we cannot use a 0 for x, there's no way we're getting a 0 for the y in this one. Those are called asymptotes on your axes. Yes? Now, transformations. I gave you this sheet too, right? Okay. This tells you all your transformation rules that we're going to use in this packet. So right now, we're going to look at your verticals, at the verticals up and down, and your horizontals, left and right, your shifts for these guys. So we base it like this, basic formula. Whatever our function is, if outside of that parentheses, we add a c or subtract a c, like this, x squared plus 2, x squared minus 2. And you've seen all along that you knew they were going up and down. This is your vertical shift up. This is your vertical shift down. Whatever c happens to be. 2, 5, whatever it happens to be. If it's inside the parentheses like this is causing a horizontal shift. And this is how you remember it. When I put in the parentheses like this, it's the closest to the x, isn't it? It's right inside the x. So where do I find the x? Here, horizontal. This takes a horizontal shift. But the thing is, this goes in the opposite direction. So instead of going left, this is going to go right too. So instead of doing this, here's my parent graph, it's going to go to the right too. And it's a horizontal thing. We have to look for any effect of your domain. But in some cases, if your domain is all real numbers, it won't affect it. If it's a squaring one, it will have an effect. So these are what we're going to be looking at. This, if you think about it, do you remember your equation for a circle? Right? The origin here would be at 0, your radius would be 2. Do you remember shifting it off the center like this? when you shifted it off the center. You took the center out of there, and the center came out the opposite way, 4, 1. The opposite one. You did this in geometry. And a little bit in algebra 2, but mostly geometry. It happens because of that, it goes the opposite way. So let's take a look at some of your transformations. We're going to sketch and describe these transformations. We're going to start with your core, your parent graph. So what function would the parent graph be for this first one? The x squared. This is your squaring function. So I'm going to start with my squaring function. You know your basic parabola goes like this. A domain of all real numbers and a range from 0 to infinity. This is your basic function, your parent. We call it a parent, we call it a core. I guess they changed the name to parent a few years ago, and I still probably refer to them as cores. Now, this is outside of my x. Where is this going to shift? Up 2. So every point goes up 2. Now, we went up. Did we change your domain or your range? Your range, because it's affecting the y. Now, watch how easy this is. So we come to the range, and we went up 2. So add 2 to your starting point. So your range is now 2 to infinity. This is your new range. Your domain did not change. Figure out where your change is. Look at how many units it moved, up or down, left or right, and work off your domain and your range the same way. So if we had to describe this change, we could say, and you got to describe these like using these words, a horizontal, a vertical shift up 2 units. This is my transformation. Okay, basic transformation. We do transformations like you would process order of operations. Parentheses and exponents, and then work your way out. So that's how you're going to decide your transformations. Okay? What's my parent graph for this one? X squared again. So I'm working with a parent graph of this, a domain of all real numbers, and a range of 0 to infinity. It looks like this one. Now, it's inside in here, so it's affecting my x, and x is horizontal. Which way is it going to go? Left. It goes the opposite way. Move this one 2 units to the left, right here. Now, because it's affecting my x, which one is it affecting, my domain or my range?
Domain.
My domain. Good. So I want to change my domain. But do I really have to since I'm all real numbers? No. So my domain for this function is still all real numbers. And I did not change the range, so the range is still 0 to infinity. And I would describe this transformation as a horizontal shift, because it's going horizontal, left 2 units. Good so far? Okay? You know, a lot of these you can put in your calculator.
That's good.
Whenever you're working off of this, let me just put one in your calculator here. Go like this, watch. Here's my parent function, x squared. Here is my new function, x plus 2 squared. Now, bring this cursor over to here where this line is and make it dark. The first time through, it's going to give me my parent graph. And then the darker one will contain my transformed graph. So watch. Here's my parent graph. Shift over to, there's my transformed graph. See it? If you have any functions that have a series of transformations, break your transformations apart and do it one step at a time, so that it works real well for that. Okay. Now we're going to talk reflections, which we have looked at reflections because we did your reflection through the origin. We did your reflection through the x-axis, through the y-axis. So we've got a reflection in the x and a reflection in the y. This is the one that we did. See, as this x changes, it goes from xy to negative xy. The easiest way is pretend you're looking at a grid like this. Take the x positive, walk over to the x negative. Where's the reflection? Over the y. So if you see me doing this with my fingers, because I'm saying to myself, if my x goes from positive to negative, where is my reflection? Over the y. If this is not changing, the x does not change, but the y becomes negative, go like this. From positive y to negative y, where is the reflection? In my x-axis. So you can take any of your grids, your court graphs, put them on your grid and reflect them. So here's our parent graph. Our parent graph is your basic square root function. We know it goes like this. We know this domain was from 0 to infinity, and its range was from 0 to infinity. We're going to reflect it in which axis? In the x-axis, because why? Because it's outside, so the x is not changing, it's changing your y. When your y goes from positive to negative, where is the reflection? Over the x-axis. So let's take this guy, here's your x-axis, and reflect it down here. This is outside, it's closer to the y. What it says is this: if I take an x of 4, and I take the square root of 4, what's the square root of 4? 2. So this point over here is 4, 2. If I take an x of 4, I take the square root, 2, and I negate it, I get 4, negative 2. See it? That's its reflection. It changed the y. When it's outside, it changes the y. When it's inside, it changes the x. So, does my domain change? Does my range change? For this new one says go from negative infinity and stop at 0. Isn't it the exact opposite of what we had? Because isn't a reflection on the other side of the x-axis? So shouldn't it be the opposite? Yes. Okay. The last part of this is we call them non-rigid transformations. And non-rigid because the shape doesn't change, but the size changes. These are your dilations. It's a stretch, it's a shrink. The regular shape of it will look similar, but it will be distorted because the size is changing. So these are kind of non-rigid. If you have this where it is a greater than 1, it is a whole number, then you've got a stretch. If you have it where it's fractional, then you have a shrink. It does not mean if it's negative. If it's negative, it's a reflection. It means this number itself. What it does is it stretches the distance to 0. It stretches that distance. So if this is my core graph, an absolute value, if this is 1, 1, let's work this out, 1, 1, we still put a 1 in here, but then we multiply it by 3 and we get 1, 3. See the stretch? It changed the distance to 0. It stretched it up. Now it looks like it shrunk it. because it's smaller, but really what it did was stretch the distance from the origin. If I do this, 1/2, it's going to take this guy, here's my 1, 1, I'm going to put a 1 in, absolute value of 1 is 1, and times 1/2, so it's going to be 1, 1/2, right here, 1, 1/2, it's 1, 1/2 right out here. It's going to stretch this. It looks like it got bigger, but it's instead of like stretching out, it's shrinking the distance to 0. It looks like it's the opposite way. A lot of kids get confused with this because it looks like, well, it's wider. But what it's doing is shrinking the distance down, so it's flattening it out. Think of it squishing it down like this. So this is a shrink in this case. It works a little bit opposite if they put it inside. If the number is greater than 1, if it's a whole number, then we call it a horizontal shrink. If you did this and horizontally you did that, it works the opposite way. I wouldn't worry too much about this. I would pull it outside and do this one, the traditional one, and that'll kind of help you. It generally isn't going to change your domain and range that much. It shouldn't, but we'll take a look at them. Now, here's a function, and when you start describing all your functions, this is tomorrow's lesson. This actually I'm going to do tomorrow. I'm just going to leave you with the basic ones today, and I'm going to do this tomorrow. Yes.
Can I go up a little bit?
Not at all. What do you need?
Oh, never mind. You didn't write anything. I thought you wrote something for H
No.
x equals F.
These, you don't need to do these as much because they work opposite. Basically bring it back out of your parentheses and keep it that way. Alright, so let me give you your homework. Hang on, guys.
We don't come in away?